In this section, we're going to talk about how do we actually evaluate our limits of integration, our upper and lower limits, if we have our complicated integrals of u substitution or integration by parts. But before we do that, we need to have just a little preliminary work on how to integrate a few of these problems. So let's say we want to integrate this 1 over the square root of x plus 7 dx. So I look at this and I don't actually know how to integrate this. I could do just 1 over the square root of x. But 1 over the square root of x plus 7, I would have to actually do u substitution. So I'm actually going to have to do u equals x plus 7, because then the derivative of that, du dx, is going to be 1. And so du equals 1 dx. And so coming back over here, this would really then be the integral of 1 over the square root of u. Okay, and then this 1 and this dx together give us du. Or this is the integral of u to the negative 1/2 du. So we take our integral, we get u to the 3/2, negative 1/2 plus 1 is just positive 1/2 divided by our new power. Don't forget your plus c. And when you're done, put all of your x's back in. So instead of dividing by 1/2, this is times by 2. U to the 1/2, that would be the square root, and we put in our x's again, plus c. So we get this 2 times the square root of x plus 7 plus c. Now note, we did this whole u substitution, which took a bunch of extra work, but the derivative of u was just 1. And if the derivative of u is just 1, that's really not very exciting. And so you'll notice as you're doing the textbook, if you need to do u substitution but the derivative of u is just going to be 1, they kind of skip doing the full u substitution and just kind of almost like cheat, maybe, if you will, because they know what the answer is going to be. So like in this example, if we want to integrate x minus 5 to the power 7, I should do u substitution, but what's the derivative of x minus 5? If u is just x minus 5, the derivative of that is 1. So instead I might say, we'll just keep that x minus 5. Let's just say that's all just kind of like one unit or one variable. Raise the power by 1, divide by your new power, and you're done. Okay, and we don't have to do the full u substitution because the derivative of u would just be 1. Okay. Let's come back up and try this for what we would have had here. This would have just been 1 over the square root of x plus 7, so we would have just said this is going to be x plus 7 to the power of 1/2 divided by the 1/2, or 2 square roots of x plus 7, which is what we got down below. So again, if the derivative of u would just be 1, you can kind of skip doing the whole u substitution and save yourself some time. You'll notice that they do that in almost all of their examples for integration by parts. And in example 4, let's evaluate the integral of 1 over x plus 6. Okay. So let's just kind of treat this whole x plus 6 as one unit because the derivative of that would just be 1. So what's the integral of just 1 over x? The integral of 1 over x is natural log. So we'll do natural log of x plus 6. Don't forget, when you integrate the 1 over x, it's natural log of absolute value plus c. So now that we have that out of the way, we can try our actual lesson for today, which is, again, evaluating our definite integrals or evaluating when we have limits. So let's say we have a complicated integral that requires u substitution or integration by parts. We'll just do the entire integral like normal and then plug in our limits at the very end. So we're really not learning anything new here. So let's integrate this. And so we have 2x over the square root of x plus 7. I usually try u substitution first, and I might say something like, okay, whatever's inside the square root, that should be my u, so x plus 7. But the derivative of that is just 1, but I have a 2x here, so u substitution won't work. So this has to be integration by parts. So if it's integration by parts, we have to go through and pick out our f of x and our g of x. So f of x I would put as my 2x because when I take the derivative of that, it's going to get simpler. And little g of x, I'm going to say square root of x plus 7. So now, from that you do f prime, or take the derivative, and I get 2. And then you integrate to get capital G of x. So this is actually why we practice up above, because we want to integrate this. Oh, I wrote just square root of x plus 7, but that was on the denominator. So we need to have it to the negative 1, or I'll just change it to x to the 7 to the power of negative 1/2. So when I integrate that, I should technically use u substitution, but the derivative of x plus 7 is just going to be 1. So I can skip that step. So I'll just say, okay, so it's going to be x plus 7, raise it to the power by 1, divide by your new power. So now that we have all that, let's plug it into our formula. Our formula says the integral of f of x, g of x, equals little f of x times capital G of x minus the integral of f prime of x times capital G of x dx. So in our case, the integral from 0 to 9 of 2x over the square root of x plus 7 dx gives me, okay, so f of x times capital G of x. F of x is 2x. Capital G of x is x plus 7 to the 1/2 over 1/2 minus the integral of f prime, which is 2, so notice that did get simpler, times capital G of x, which is x plus 7 to the 1/2 over 1/2 dx. Okay. This 2x divided by 1/2 is going to be 4x, and we'll go ahead and change that to the square root of x plus 7 minus, so the 2 and 1/2, or 2 times 2 divided by 1/2 should actually be 4. Okay, now x plus 7 to the power of 1/2, we need to raise our power by 1 and divide by our new power. And when we integrate, we do plus c. But in this case, they actually gave us limits, so let's evaluate it from x equals 0 to x equals 9. Notice I didn't really care about that until I got to the very end. Also, remember what's going to happen, our c's will cancel every time. Okay, so this is going to be 4 times 9, square root of 9 plus 7, minus, and let's see, 4 divided by 3/2, let's just simplify that. 4 divided by 3/2 is 8/3, times 9 plus 7 to the 3/2, plus c, minus, now we do zeros, 4 times 0 times the square root of 0 plus 7, well that's going to be simple, minus 8/3 times 0 plus 7 to the 3/2 plus c. Which gives me 22.7. So again, this was integration by parts. We didn't do anything new here. We just waited until the very end and then plugged in our limits of integration. Okay. Now though, we're going to try one with u substitution. We actually will learn a new trick. So let's integrate from 0 to 7, x squared times x cubed minus 2x. Now when I look at this one, I say, okay, u equals x cubed minus 2. That would be my first guess, because that's what's inside the kind of more complicated square root. And the derivative of u, and now the derivative of u is going to be 3x squared, and du equals 3x squared dx. So if we come back over here, this x cubed minus 2, that would be my u, and this x squared and dx, that's almost du, except what am I missing? I'm missing a 3. So what I need to do is rewrite this. I'm going to write it as 1/3 times the integral from 0 to 7 of 3x squared square root of x cubed minus 2 dx. The reason why is I need that 3 in there, but if I put a 3 in, I have to put a 1/3 on the outside to keep it balanced. Now with all of that, we can say, okay, now this is 1/3 integral And I'm going to leave off my limits. I'm going to stop writing that 0 and 7 for a minute, and I'll tell you why when we get to it. So 3x squared and dx together, that's just du. And square root of x cubed minus 2, that's going to be u, or square root of u. So we just have square root of u du. The reason I didn't put my 0 and 7 is now I have u's, and these were x's. Okay, we don't always write it, but these limits are for x's. That's x equals 0, x equals 7. So I don't want to put them here with the u's. That's going to be confusing. So let's just leave it off for a little while. Or this is 1/3 times the integral of u to the 1/2 du. So this is 1/3 times, we're going to have u to the 3/2 divided by 3/2. Okay. We would normally do plus c, but since we are evaluating at the very end, we could skip it, or you can go ahead and put it in. So 1/3 divided by 3/2 is 2/9. So we have 2/9 u to the 3/2 plus c. Okay, so that's kind of a partial answer. We're getting part way. But our final answer, or we started with x's, so we should probably finish with x's. So let's go ahead and put our x's back in. So 2/9 times x cubed minus 2 to the power of 3/2 plus c. And now we want to evaluate that from x equals 7, or x equals 0 to x equals 7. And I put the 0 and 7 back in at the very end, back when I had x's again, because those numbers were for x's. So this is going to be 2/9 times 7 cubed minus 2 to the power of 3/2 plus c minus 2/9 times 0 minus 2 to the 3/2 plus c. I just barely realized putting this in my calculator that I picked limits that we cannot actually integrate, because right here, this -2 to the power of 3/2, that means we're actually taking the square root of a -2, and we can't do that. So let's go back through just really quick and change this to, let's integrate from 5. Let's change that to a 5. And this is a 5. And this is a 5. We don't want to have to start all over and redo all of our hard work. So if we go through and we evaluate at 5 instead of 0, because that gives us an answer that we can't do. Okay, we need to put in the 7 for x, so it'll be 7 cubed minus 2, and put in the 5 for x, so 5 cubed minus 2. Our c's cancel, we get 1096.2. Okay. So this is the nothing exciting method. Okay. And you can do this without learning anything new. You just wait till the very end and plug in your limits. Okay. Or you can do method 2, which is just a little bit simpler. Your algebra is a little bit simpler. There's less to put in your calculator, and you save yourself a step. So method 2 is change to u limits. And so by this, I mean if x equals 5, then what does u equal? U, which equals, come back up, u is x cubed minus 2. So u equals x cubed minus 2. So then u is going to be 5 cubed minus 2, which should be 123. And if x equals 7, then u equals 7 cubed minus 2, which is 341. Okay. So you change to u limits, and then when you get to the step that says 2/9 u to the 3/2 plus c. So once you've integrated with u, you don't have to actually go through and put your x's back in. You can just evaluate it here from u equals 123 to 341. So you can do it with the u limits instead. So this will be 2/9 times 341 to the power of 3/2 plus c minus 2/9 times 123 to the 3/2 plus c. This is easier to put into your calculator, and we still get 1096.2. So two different methods. One is just do your U substitution exactly like normal, wait until the very end and put your X limits in. Method two is change and get U limits and plug them in when you get your integrate and get an answer with U. And you save yourself some work and sometimes makes it a little bit easier to put into the calculator. Okay. So that's what we have here. After integrating, you can plug the X's back in and then use the X equals A, X equals B limits, or you can change the X limits to U limits and save a little bit of time. It's completely up to you. It does not matter which way you do this. Let's do one more example. Let's evaluate from 1 to 6, x cubed times x to the 4th minus 1 to the power of 8. So when we look at this, u is going to be x to the 4th minus 1. The derivative of that would be not 4x cubed. And du is 4x cubed dx. So coming back over here, it looks like I only have an x cubed, so we need to put in the 4. So we now want to integrate 4x cubed times x to the 4th minus 1 to the power of 8 dx. But if I add in the 4 or multiply by 4, I need to put a 1/4 on the outside so that I'm not changing it. I'm going to leave off my limits until the very end because soon my x's are going to become u's. So this is going to be 1/4 times the integral. Notice that 4x cubed and dx all together is du, and this x to the 4th minus 1 is u, so it's going to be u to the 8th du. So I integrate that. I still have the 1/4. This will be u to the 9th over 9. And normally I do a plus c, but at this point, let's not bother because we know we're evaluating, we know we have limits. So let's stop here. We do need to use our limits, but we have two options. So method one is x limits. So if we want our x limits, our 1/4 u to the 9th over 9, or let's change that to u to the 9th over 36, would actually be equal to x to the 4th minus 1 to the power of 9 over 36. So we'll evaluate it from x equals 1 to x equals 6 because those were our original x units. So this is going to be 6 to the power of 4 minus 1 to the power of 9 over 36 minus 1 to the power of 4 minus 1 to the power of 9 all over 36, which should give me 2.84 times 10 to the 26. So that's a big number there. Or method 2, we can change to u limits, where u equals x to the 4th minus 1. So if x equals 1, then u equals 1 to the 4th minus 1, which is 0. And if x equals 6, then u equals 1295. So we have u to the 9 over 36 evaluated from u equals 0 to u equals 1295. So we're going to have 1295 to the power of 9 over 36 minus 0 to the power of 9 over 36. Again, the biggest advantage to doing it this way with your u limits is that it's a lot easier to put into your calculator. So 2.84 times 10 to the 26. But you can choose between whether you use your x limits or u limits. If it's easier for you, you don't have to learn any new stuff, just use your x limits. But u limits are usually a little bit simpler to put into your calculator and will save a little bit of time.